Today we're going to start with uh, modern methods of irrigation. The first modern method of irrigation that we are interested in is perennial canals, right? So basically they are same as inundation canals, which we studied last time, right? But the only difference between inundation and perennial canals is that these canals are taken from dams, from water reservoirs, right? What do you mean by water reservoirs? It's any storage, water storage capacity, right? Water storage capacity. So that is called the water reservoirs. So perennial canals are connected to the water reservoirs, and therefore they are able to supply water throughout the year. Does that make sense? Right, so their water supply
Yeah,
is not,
that makes sense.
yeah, so their water supply is not restricted just to the monsoon season when the rivers are flooded, right? So the difference is that so for instance, if two canals are shown to you, one is taken from river and the other one is taken from let's say the Mangla Dam, perhaps, just to give you a sense. And the examiner asks you to classify this canal and this canal as a modern or traditional method. So what will you say? You're gonna say that this canal will be definitely a traditional one, right? And it's called inundation canals, right? Inundation canal. And then on the other hand, you have this modern method of irrigation, the canal which is taken from the dam, and you will call it perennial canal. Does that make sense? So this is the basic difference between inundation canals and perennial canals. Perennial canals look like, these canals look something like this. And as you can see, some features, the sides are, solidified. They are solidified, right, by mud, solidified sides. Why do you think that these sides are solidified? There is a reason behind that. There is a reason behind that. So these are solidified because
You're asking like why it's naturally
uh,
solidified or like man-made?
no. So it's, you can clearly see these are man-made structures. These follow a systematic,
Yeah.
building method. So these are clearly man-made. But why do you think these sites are actually solidified? What's the rationale behind solidifying these sites? These are solidified so that the water, flows in a
To
single,
keep them from overflowing.
not overflowing, rather the water, continues in the same passage, right? The water is not wasted actually, right? To reduce waste, water waste, or in technical geography, we call it, it's seepage or water loss, right? So to prevent that from happening, these canals are solidified with muds, right? So okay, so let's talk about some of the restrictions, some of the problems with perennial canals. First thing first, you can see it's an open space, right? And if the space is open, there is always a risk of evaporation, right? So there is a risk of evaporation. Similarly, unfortunately, in Pakistan, particularly in Sindh and Punjab, these canals are unlined. These canals are unlined. What do you understand? Any random thoughts on what do we mean when we use the term unlined canals?
It's like natural and unlined. Like usually people would put them in like specific terraces or something, or it would be in a straight line. But unlined would like
Yes,
go
yes,
out every other way and not in a
absolutely.
straight.
Absolutely. So it's not, more or less, you could say that they are not standardized in their in their way of transporting water, right? They are built in a haphazard fashion. So something roughly, just to make sense. This is one canal, this is third, something like that, just like tic-tac-toe, right? So what happens actually is that if the canals are unlined, it results in seepage. Seepage means loss of water through leakage, in easiest of words, right? When your water is lost through leakage, that is how you roughly define seepage, right? So the second problem with this method is that you have your seepage, right? um, let's talk about some monetary aspect of this method. So unfortunately or fortunately, as you like to call it, every modern method has got two common limitations. The first one is that installation cost is high. Installation cost is high. It means that if you want to set up that method, you will require a lot of finance. And secondly, their maintenance cost is also high. So these two limitations are common limitations across all modern methods, right? For all modern methods, you have these two limitations. So analogically, similarly, you have these two limitations for perennial canals as well. Now, let's talk about another problem which we face if perennial canals are used, and that is the deposition of silt, right? It's the deposition of silt. Now, can you please try to sort of elucidate or try to define what is silt? I'm not looking for technical definition, but being a PhD student, how do we define silt?
I think maybe a silt would be like a deposit, like a line, a deposited line or
Uh,
something.
no. Sure, the matter that we term as silt can be deposited as a line, but the defining features of silt is that these are particles of sand, or you could say mud and small stones and pebbles, right? Does that make sense? So what happens is that suppose uh, let me give you a scenario here. So suppose that you have your, canal right here, right? Your water is flowing through it, and definitely the water is carrying in itself small particles, of sand and mud, which we term as silt. Now, since the flow of the water is too fast, now let me put it here. Since the water flow is too fast, now I would ask you, why is this the case? Before I move on, why is this the case? Why is the water flow too fast?
Because maybe the I need time. Wait, like maybe the flow of the river is fast,
Uh,
or
Not the river
it's in a slope.
actually.
It's in a slope way, like a sloped land.
Sure, that's absolutely true. But another reason is that because they are connected to reservoirs, right? Connected to reservoirs. So if the canals, if you consider the case of the inundation canals, those are connected with the rivers, and they only flow when there is flood in the river, right? And during the monsoon season. So there would be less deposition of silt, right? But in the perennial canals, the water flows all across the year, and it brings a lot of silt, right? It keeps on flowing, it keeps on bringing, keeps on flowing, keeps on bringing. This cycle repeats, and therefore your particles, get deposited, and they are deposited like this. A layer is created, actually, silt layer. Are we clear on this? Do you have any question
Yes, we're
related to
clear.
this?
No, no
Okay,
question.
but I have a question for you. Now, if
Right,
I want to reduce this, I want to overcome this problem, can you suggest,
right.
can you suggest me two measures to overcome this? Now, see, in this way, it's not just a random question. This will actually help you. It's more or less related to your past papers, right? So it will help you there. So if you can suggest me two ways. Now, let me share a trick with you. The easiest way uh, to get rid of a problem is to reverse that problem, right? So in geography, you will see that this is applicable almost everywhere where we study the problems and the solutions, right? So, be it a fishing
Right.
industry or any chapter. So if you are getting silt deposit, it's a problem. So how are you gonna reverse it? So think, why is the silt being deposited? It's because there is consistent flow of water. So what you can do is that you can control water flow. Yes or no? So
Yeah.
automatically your deposition of silt will be controlled. And another method that you could use is that you could establish alternative ways of irrigation, perhaps that
Yeah.
do not result in much silt deposit. For instance, tube wells, right?
Yeah.
So yeah, so this is what perennial canals are, and how they work actually. And I'm pretty much sure that if you haven't studied this chapter before in school,
Right.
have you studied it?
Yep.
Have you studied in this much detail?
No, not in this much detail though.
Yeah. So the reason is that because the way I teach is that you will find it very, very easy to attempt the past papers. When we will do the
Yeah,
past paper,
it's much easier
yeah.
because our teacher, she's just like basically she doesn't even draw a diagram or anything. She just tells us to take our books out and read it.
Hmm.
And if we ask questions, so she's just like, "Why are you asking me questions? Just read the book."
Which school are you from?
Beacon House
Beacon
in
House,
Peshawar.
Peshawar campus, right?
Yep.
All right, all right. Okay, okay. Let's move on. So next, second method is called tube wells, right? It's a really really common method. It's really common in Sindh and Punjab. Really really common. Okay, okay. So just see this. I want you to forget everything for a couple of seconds. Just enjoy it. Aesthetic. It's aesthetics, right? So just take a few seconds and see what is happening. And if I might ask you, where is this water coming from? What do you think?
Sorry to but your screen it just like turned black.
Is it still visible? Is it not visible now?
Yeah, it's like black.
All right. No, it's visible to me. Just a second. Just a second. No,
It like says you started screen sharing and it loads and then it just turns black.
is it visible now?
Nope.
Okay.
I don't know, like after you said let's continue, it just turned black.
All
And I
right.
thought it must have been my network, but it's
Uh,
yeah, okay, we stopped.
okay. Now, is it visible now?
Wait, it's loading. Yeah, it's visible
Can
now.
see your application. All right.
Yeah, yeah, I
Perfect.
can see it.
Okay. Perfect. All right. So let's now. I want you to take a couple of seconds and just look at this diagram. Mm, Uh,
Right.
where do you think this water is coming from?
Probably underground.
Yes,
Yeah, it's from
it's
underground.
it's coming from underground. This is your pipe. It's a metal pipe. This can be seen. This is what this you can call it a container. right? For the water, and this container leads to, it leads to the field actually. All right. Oh, okay. Now the question is, this is another pipe right here. All of this work is, it's all metal. Now the question arises, where from underground, how the system is actually working. Now, unfortunately, this is an aerial view. Let me take you underground. All right. So what happens is that underground, you have, I will just show it you. Okay, so underground scenario is this. This is your surface, right? And this is your underground water. All right, so this is your underground water. Now, this underground water, of course, we all know that there is water underground. So this underground water. Now, I want you to learn this important word, which is called water table. Water table. Now, if someone asks you, what is water table? So you would define it as, water table is the level of water underground. Simple as that, or below the surface. Right? So this is called water table. Now, what happens is that what farmers do, they insert a metal pipe, as we are able to see, right? This metal pipe, right? They insert it in the ground, and this metal pipe has a pump attached to it. It has what? It has got a pump. Now it has a pump attached to it. Now this pump actually acts as a suction machine. Acts as a suction machine. Now it brings water up. Are you getting my point? It brings water up. It
Yep.
sucks the water up. Now, let me give you a very, very mundane example. Consider that you have a drink in your hands. The drink you are holding a drink right in front of you, right? And then if you want to drink it, you are gonna use a straw, and then you are gonna pull it, right? You are gonna suck it, you are gonna drink it using your mouth, right? So just like we use straws for our drinking purposes, this pump acts as a straw attached to a human, right? It sucks water up, right? It brings water up. Now, listen to this very, very carefully. Okay, so suppose uh, this is a person, right? He wants to drink this juice. All right. Now there are two ways to drink this juice. He can use a straw. He can use a straw, and he will suck it. He will get it, right? He will actually consume it. And then there is another method that he could use. Suppose this is your juice. He can use his hands to pull the container, to pull the juice back. So now there are two ways. In one way, the container remains at its place. No movement of the container. He is using the straw. But in the other method, he is going to bring the container up close to his mouth and drink from it directly. Are you clear on these two situations?
Yep.
Okay, so now can you tell me which situation correlates to tube wells? Now, tube wells do what? Are they bringing the water level up, or they just or the tube well just keep the water table at its place, and the suction machine just sucks the water up?
No, I think it's number one. I think the water is at like its own what do you call it?
On
Like
its level,
natural.
right?
Yeah, on its own
Yeah,
level, and the
yes, yes,
pipe
yes.
is quite
Yes,
under. No.
absolutely, because you are not bringing the water level up. You are just, the water level is right there.
Yeah.
You are using a suction machine to bring it up. All right. So now listen to this. Now, when the water table rises, when the water table rises, in geography, we call it water logging. We call it water logging.
Okay.
So
Right.
water logging can be defined as increase in the level of water, right? Underground water level increases, you call it water logging. Okay, now, so far so good. Okay, so now consider this. When your water level will rise, right? What will happen next? If your water level rises, this is your, let's say, if water level rises, or in other words, you could say if there is water logging is ultimately rise in the water table. So what will happen? This is your surface. If your water has risen, it has come above the surface. And right here you have your sun.
Right.
Now the sun will, owing to the radiation of the heat, the water will start evaporating, right? The water is gonna evaporate.
Evaporate.
But,
Right.
but, but, salt will be left behind. Salt will be
Left behind.
left behind. And afterwards, what will happen is that if waterlogging occurs, now the water will evaporate, but salty patches will appear on the land. Salty patches will appear on the land,
On the
right?
line. Right.
And in geography, the examiner says we want candidates to define it, to use one word for this, and it's called salinity. It's called salinity. Does that make sense to you? Right? So are we
Sorry,
clear?
that was my alarm.
No worries. So are we clear on that? What is salinity?
Yep, we're clear.
Okay, okay, perfect, perfect. Now why I sort of explained to you both of these things. Now, coming back to tube wells. So since we have established that tube wells do not make water table rise. So this is an advantage, because if water table is not gonna rise, salty patches or salinity will not gonna occur. And if salinity is not gonna occur, your land will remain fertile. Otherwise, if salinity is gonna occur, suppose this is your land, and salty patches will occur like this, and what will happen eventually? The land will lose its fertility. Land loses its fertility. So this is an advantage of using tube wells, right? This is an advantage. What is the advantage? It reduces waterlogging and salinity. Does that make sense?
Yep, made sense.
Okay, now if I ask you, okay, so let's see, what progress have you made in terms of answer writing technique? State one advantage of tube wells. State one advantage of tube wells. So now you are gonna just write this. You are gonna get 1 mark, right? But if the question says to you, the question says, let's say, explain two advantages of using tube wells. So now what you are gonna do, simply, you are gonna start with this. So I will write it here. Number one, reduces problems of waterlogging and salinity. Now, how will you develop it further? You will write land's fertility remains intact. Are we clear on this?
Yep, we're clear.
Yes, right? So this basically, this part is the identification of the point. This is the identification. And then uh, this part is actually, this part is the development of the point. All right. This is development which you need to do for a 4-marker question in which the keyword is explained. All right. So, and similarly, if you compare, let's move to other advantages. As you can see, there is a fast, fresh, continuous supply of water. So it's another advantage. And since the water supply is continuous, it will be, the farmer will be able to irrigate a large area. Commercial farming will become possible. What is commercial farming, just by the way? Done to earn profit, right? On a large level. That is what commercial farming is. And similarly, if you remember Charsa or Shadoof, both of the
So
methods.
it's basically like farming like a single crop over like a lot of land.
Yeah, sort
Like
of
if it's
that.
like rice, so you would take like the whole plot just to
Yes, so that you
grow
can,
rice.
yes, so that you can, sell it into the market and earn monetary benefit, earn profit, right?
Right, right,
All right.
right.
And and another advantage of this method is that you are not dependent on animal or labor, less dependence on animal and labor, because the system works on its own. Now the question arises, sir, how does the system work on its own? Okay, you have mentioned that the pump is there. Now how this pump works? Now this pump works through This pump works through what? Through diesel or electricity. It works through diesel or electricity, right? So this is a limitation of this method, right? So for this method, you need what? You need to have access to electricity, and or you need to have diesel. So do you think a subsistence farmer can afford this method? Really not, right? Because
I don't think so. Yeah.
yeah, because diesel is quite expensive, and then you have your electricity problems, right? So there are certain limitations. It's expensive, high maintenance cost. It's very expensive to install them, right? And it requires electricity and diesel. So there is a mistake. It's just a typing error. Right? So tube wells do not cause waterlogging and salinity. Rather, they help to reduce waterlogging and salinity. So, okay, do you have any questions related to tube wells?
No, I don't have any questions.
Okay, shall we move on?
Yep.
Okay, now, have you seen any of these in a park, in a public park?
Um, no, I haven't. Like, yeah, I have seen these before.
These are
Not
usually placed
really.
in, these are usually placed in gardens, and so basically they are sprinklers, right? They are what? They are,
I've seen them at home though. We have one at
mhm,
home.
right. So these are
I've seen
sprinklers,
how it.
right? So these are sprinklers. They are connected to public, water lines. These are connected to public water lines. What are public water lines? These are connected to public water lines. Public water lines. What are public water lines? Just by the way. So it's basically
Um,
government provided
yeah, yeah,
water lines, right? And these are usually placed in gardens, right? An institute like IBA, it's a well-renowned university of Pakistan, can afford these sprinklers, right? Because these are quite expensive, and but you would rarely see these on farms, right? So these are rarely seen on farms, rarely used on farms. Why these are rarely used? Because they are quite expensive, right? They are expensive. Another problem with using these sprinklers is that if there is heavy thunderstorms, right, or heavy rainfall, there is a risk that if this rotating device, if these sprinklers are made of are made of plastic, or they are made of weak material or weak metal, they might just blow away, right? In when there is heavy rainfall, thunderstorms, right? So there is a risk that they might just get destroyed by heavy winds. So this method of irrigation is called sprinklers or spray irrigation, right? So what happens is that a farmer places a sprinkler in the field, right? And it rotates and it spreads the water all across the field evenly, right? And just by the way, just for on a side note, um, there are certain sprinklers. For instance, this is your surface. You have placed your sprinklers. There are certain sprinklers uh, that rise on their own, that are mechanized, and then they also, they also rotate and spread water. But this is these versions are quite advanced, and in Pakistan we do not use them for they are very expensive, and this system actually depends on electricity, right? So there are certain limitations as well. These are expensive, depends on electricity. Winds can destroy the mechanism if they are made of weak materials. And of course, as you can see that in such a small space, you need three sprinklers, right? So they irrigate a small piece of land technically, but they are also beneficial. If they are installed in Pakistan, they have certain benefits as well. Do you require any animal for this to work, for the system to work? No, right? The system is automatic, right? It's less time consuming, and the water supply,
no.
yeah, and the water supply can also be controlled, right? So,
Yep.
so these are some of the benefits, right? Less water is wasted, water supply is controlled, you can control it anytime, turn on or off, it's in your hands, being the farmer. No time, less time is wasted. You could perhaps, as a farmer, find another job in this save time, instead of just working on the mechanism of irrigation. Uh, and similarly, you don't require any labor or animal as such. So are we clear on this? Sprinklers or spray irrigation?
Yep.
Okay. Now, so tankers. So, uh, you know, if we would have been meeting in person, what I normally do with my students at coachings and at the schools in which I teach, what I do basically, uh, I randomly take any number and make a call to the tanker owners just to, uh, why I do that, I'm going to tell you in a while. But before that, let me tell you how this works. So these are cars. You can see that it's a huge container, right? It contains thousands of water gallons. And now the question arises, okay, sir, I understand that the companies that supply water through tankers, they provide door-to-door service. They come to your house. They provide you with the water. But where do these tankers collect water from? So they collect water from nearby rivers or lakes or ponds, right? They collect water from these sources. They gather it in a sum of thousands of gallons and deliver it from home to home, provides door-to-door service. So if you live in a city where the public water supply lines that reach our that come to our homes, for instance, take the example of Karachi. Many areas in Karachi uh, you know, are void from fresh water, right? So these tankers actually come very handy, right? These tankers supply water from door to door, right? So and just by the way, since I don't have a good experience with these tankers, they are on a side note, just take it on a light note. So they are actually key enemies of bike riders, right?
So did they like accidentally run into you or something?
uh, I mean, I just try to stay away at least 1,000 steps away from these, but uh,
From
but
the
but
bike tankers.
but there is a logical reason, since these are too high. The driver is
Yeah,
seated right above, so he's unable to see a small bike riding, motorcycle riding, motorbike riding.
right,
So they
right.
just, oh my god, Allah saves all of us. All right. So okay, so Uncle Tanker.
Um,
Yes.
where I was with like my dad, they had
uh,
like these. They weren't like tankers, but there
uh,
was like a tanker for petrol, and they were coming to
just
like
a,
door
just a,
to
just
door.
a second, beta, just a second.
Right.
Can Since the meeting is gonna end, right? So can you
Yeah.
please rejoin?
Yeah, of course. Sure.
Okay, so kindly rejoin first. Okay, we'll
Okay.
yeah, please.
Yeah, yeah, okay.